Well, greetings everybody. Let's look at this problem right here, which I've taken directly from the assignment on MyMathLab, which I'll summarize like this. We're given a function and we want to find the derivative. In other videos, I've explained the difference between the function and the derivative and what the derivative tells us that the function doesn't. I won't do that here because the objective with this assignment is to learn how to use the rules that we have to find the derivative. Okay, so what I've done is I've written out these rules for derivatives right here. It says, like, for example, the derivative of x to the n power is n times x to the n minus 1 power. Okay, so that's a rule that if you wanted to find the derivative of x to some exponent, whether that exponent's a fraction, a positive number, a negative number, this is what you do to find the derivative. There are lots of other rules though, okay? So I wish I could tell you there was just one rule and it's always very easy to decide what to do, but I don't think that is the case for everybody. So we've got this other rule that says if I have a constant times a function, I can find the derivative of that by carrying that constant into my answer and multiplying it by the derivative of that function. Okay? Then I've got this third rule that says if I have one function plus or minus another, I can find the derivative of that sort of thing by just carrying the plus or the minus down into my answer and finding the derivative of these functions individually with whatever rule would be appropriate. Okay, now all these are going to be in play here. One more thing though, whenever we start learning algebra and then we begin to learn calculus after that, our standard variable is x, okay? But we don't always use x as the variable in practice. Like we might use t for time, r for revenue, p for profit, and so on. So there could be lots of other variables. So here I look at this one, it says r equals 1/5, 1 over 5 s to the 4th power, so on. So the variable there is s instead of x, but that's not going to change the fact that the rule is applicable, and it doesn't change how it applies either. Okay. All right, so here goes. I think that in order to use these rules to find the derivative of this, I'm going to have to rewrite it some other way. Because this is the rule that we have. It says you have a variable to a power. It doesn't say you can have 1 divide by the variable to the power or 7 divide by. It doesn't say that that this would apply to a fraction. It doesn't say that this would apply if your variable has a power but it's under the fraction bar. That's just not the way the rule looks. It doesn't work that way. It doesn't apply like that. So what I have to do is rewrite it so that this variable s, or s to the 4th power, s to the 3rd power, is not under the fraction bar. Okay, so I can do that if I know a little bit about how positive versus negative exponents work. So okay, I've got more rules for you, but that's the way it is. I can't change that. There's just lots of rules for how you do things when you learn math. So here's my rules for exponents that I'll need to call upon. If I look at this, you see how the exponent's positive here and it's negative there? So I know I squeezed in that negative sign kind of tight, but what that says is if I can move this thing, this x to the power n, I can move it under the fraction bar, and what will happen is the exponent will become negative. Or if I have it like this, say that the x to the power is under the bar to start with, I can move it on top, and then what happens to the exponent? The exponent becomes negative. Basically, anytime you move something from above the fraction bar to below or below to above, the exponent switches signs, okay? So here goes. In order to rewrite this original function in a way that this rule applies, I will go like this. I'll say, okay, if I have s to the 4th power under the bar, that means I have s to the minus 4 power above the bar. If I have s to the 3rd power below the bar, that means I have s to the minus 3 power above the bar. Okay? So I start by doing that, and then I want to do one more thing. I could write s to the minus 4 power over 5, but I think it would be a little easier to see it as 1/5 times s to the minus 4 power. Same thing. And I could write 7 times s to the minus 3 power all divided by 4, but it is the exact same thing as 7/4 times s to the minus 3 power. Okay, so now I've got it rewritten in a way that these rules are applicable, right? So here's what I do. First thing, I can carry down this 1/5 into my answer. I don't have to do anything with this 1/5 at all, okay? That's what this rule says. If you have some constant, some fixed number times your formula, just carry it into your answer. So this 1/5 gets carried into the derivative. But then how do we find the derivative of s to the minus 4 power? That's what this rule is applicable for. I've got my variable to a power. What's it say to do? I bring that power down to the front. Okay, so the negative 4 power gets brought down to the front right there. And then what do? I subtract 1 from it. Okay, and then what's minus 4 subtract 1 is minus 5. So what you're looking at here is bring down the 1/5, and then here power comes to the front, then subtract 1, and we're looking at that. Okay, what do I do with this subtraction right here? And I'm working my way through this. Now I'm to the subtraction. Well, I can carry that into my answer too. That's what this rule says. If you have f plus g of x, one formula plus or minus another, you find the derivative of that by, you can just carry the plus or the minus, whatever it is, into your answer and find the derivative of each of these on their own. So this subtraction, carry down. What about the 7/4? Carry down. And then what? Then the derivative of s to the minus 3 power. How do you do that? That's what this rule is for. Take that negative 3 to the front, and then what? Take away 1 from it. So take the negative 3 to the front. It's like that. And then what's negative 3 take away 1? Negative 4. All right, so that's all 3 of these rules in some kind of interplay in one problem. They're all working together. I got to know that I carry down the 1/5. I carry down the 7/4. I carry down the subtraction. But for these individual formulas, s to the negative 4, s to the negative 3, I use that one. Okay. Now from here, let's combine some things as we can. I get, this is all multiplied. This says 1/5 times negative 4 times s to the minus 5. I'll go ahead and multiply 1/5 times negative 4. That's negative 4/5 right there. Here I have negative 7/4 times negative 3. That is, well, so first of all, a negative times a negative, that's positive. So notice the plus right there. And then 7 times 3 is 21. So it's positive 21/4. All right, one more thing. You might be able to leave your answer like this. I can't say MyMathLab is always entirely consistent about the answers that it accepts. So let me just tell you that maybe, see this thing right there that I did not put in the red box, maybe it would accept that as the final answer. It's okay, it's simplified. We wouldn't want to leave the 1/5 and the negative 4 part. I mean, combine those, combine what you can, but when we've done that, it might be okay to write this, okay? But sometimes you might be required to simplify those exponents. So can I see these terms with the exponents, s to the minus 5, s to the minus 4? Could I move those? Okay, can those be somewhere else and me not have negative numbers? Like if I don't have to have a negative, then maybe I would avoid it. All right, that's all I'm trying to say. Can these be moved? Can you move those so that the exponents aren't negative numbers anymore? Well, remember these rules for exponents I said. I can write them down like this, but the gist of these rules for exponents is if you take something that has an exponent and you move it on the other side of the fraction bar, what happens to the exponent? It changes sign. See how these are opposites of each other? N and negative n, either way. So I could take these, I can move them under the fraction bar, and they will become opposite of whatever they are. So negative 5 will become 5, and negative 4 will become 4. And so I'll give you my final answer like that. That is the final answer given in the question here on MyMathLab. All right, so I think you should expect to carry it all the way down to that Okay, so bad news is there's lots of rules that you have to think about when you're doing this. And right now, this part of our class, we are learning to use the rules. Okay? All right, so yes, there's lots of rules to think about, to know about, to understand how to use together. That's the bad news, is that it might seem a little overwhelming at first because there are so many rules to think about. Good news is, I think if you see enough examples and you consider what I said here, then it won't be a problem for you.